Hey everybody, today we're going to solve the fair candy swap problem on LeetCode. LeetCode has a new layout here, so it just looks a little different, but let's go through the problem definition. Alice and Bob have candy bars of different sizes, and they're friends, so when they exchange one candy bar, they want to make an exchange so they each have the same total amount of candy, okay? So they each have a set of candy bars, and they want to make one exchange so that once they make that swap, their total number of candy is the same. And we return a integer array where the first one is the candy bar Alice has to exchange, and the second element is the one Bob has to exchange, their sizes. And we're guaranteed an answer exists, which is important. Alright, so solving this problem just comes down to a math problem, and I'll just talk through it really quick. It's pretty simple, just some algebra. So the sum that Alice has, the total sum of candy that she has, minus the candy bar that she gives up, plus the candy bar that she gets, has to be equal to the sum of the candy that Bob has, plus the candy bar Alice gives up, minus the candy bar that Bob gives up. Now what we can do is we can solve that equation for the size of the bar that Bob has to give up, and that will be equal to the size of the candy bar Alice gives up, plus the sum of Bob's candies minus the sum of Alice's candies divided by 2. So that's the end equation that we end with. So the end equation that we end up with is the size of the bar that Bob has to give up is equal to the size of the bar that Alice has to give up, plus the sum of Bob's candies minus the sum of Alice's candies all over 2. Okay, so that's all we have to do. What we're going to do is we're going to use a hash set. I'm going to call B candy, have Bob's candies in there. It's going to be a new hash set. This is going to keep track of Bob's candies so we can see if he has the values that we need in constant time. Our integer array answer would be integer array of 2. A is going to be the sum of Alice's candies, B the sum of Bob's candies. Start those guys at 0. For each candy that Alice has, we're going to do her sum plus equal to x. For each candy that Bob has, we're going to update his sum so that B plus equals x. And we're also going to remember it. So B candy is going to add x. Now again, the difference between them, or the size of the bar that Bob has to give up, so just call it Bob bar, is equal to, and this was the equation that we solved, the Bob bar size is going to be Alice's bar plus the sum of Bob's candies minus the sum of Alice's candies all over 2. Now, that's an equation in 2 variables, Bob's bar and Alice's bar, which have yet to be determined. So instead of calling it Bob's bar, we're just going to call it diff, which is the difference between the 2 bars that we have to find. And that is equal to the sum of Bob's candies minus the sum of Alice's candies all over 2. Now all we have to do is go back through Alice's candies. If Bob's candies contains x plus diff. Now remember, x here is the candy bar in Alice's possession. And the difference is the difference between the two that we calculated in that equation, in that algebraic equation. Then if that's the case, then we found our answer. Ans of 0 will be x, the one Alice has to give up. Ans of 1 will be x plus diff. And then we're going to break out of here. This really fun little modular window they have here doesn't make it terribly easy to see where the code ends. Let's see what that does. Semicolons, Java, they'll get you. Looks right. It is right. Okay. So all we did in this problem was figure out an algebraic equation to solve for the size of the bars that need to be exchanged. And then we just went through and looked for them. So this hash set lets us look up Bob's candies in constant time. So this is a linear runtime solution, because down here, when we're looping back through Alice's candies, we can check if Bob's candies has them in constant time. And then once we found it, we found the difference, and we just return those two.